new SOILveR Coffee break. Or record it. And indeed, this meeting will be available afterwards on our website. The topic of today is ecological index of concerns, supporting ecological soil function restoration. So I will give you some word of introduction on SOILveR, and then after we will pass on the word to our speakers of today. First, on the triad approach by Nicolas from INERIS, expert in ecological risk assessment, and then another colleague of him talking about the development of ecological index of concern, Nicolas Pucheux. And then the third speaker will be Cécile from ADEME, project manager of that project, and she will give us some word on how to use such ecological index of concern for land management. After those presentations, we will have the question and answer session, and we will try to end the meeting at 2:15. So first, some word what about SOILveR? Some historical considerations. So at the very beginning, in 2003 until 2015, that was the Snowman network. That was at first an ERANET, co-funded by EU until 2009, and then it went on self-financed because the interest of financing transnational research was very high. We then were waiting the strategic research agenda that was going to be produced by the Inspiration project, European funded. And during that time, we did a kind of a low profile activity. And then after, with that strategic research agenda, we took it on board and transformed our names to become the SOILveR platform. And we are running since 2018. What do we do? Of course, we want to fund research, project on soil and land, but we are more than that. We try to also ensure the involvement of highly competent and skilled researchers and other types of committed stakeholders from across Europe. We also facilitate exchange experiences between the members of our platform on specific topics. And from the research crowdfunding, we want to produce operational research results, such as guidelines, recommendations, decision support tools, new technologies, and other types of deliverables. Here you can see that we have ADEME, which is member, the Swedish Geotechnical Institute, the Ministry of Infrastructure and Water from the Netherlands, and then institutions from Wallonia, Belgium, SPAC, and the administration, the Ministry of Environment. We are working on different topics, but the topics of common interest are really related to the EU soil strategy and especially to the upcoming soil health law. So here there is a list of topics that we are working on. So risk assessment in the context of polluted soils, circular economy, ecosystem services, soil and land restoration and monitoring, and also the value of soil and awareness raising on that. We are organized on two pillars. The first pillar is focused on the knowledge exchange. So the idea is to share the different results from research. And we do that through different type of meetings. So open public online meetings for everybody, like today. That can be webinars or hotspots or coffee break. And also we have, of course, internal meeting to exchange on selected issues. And we also collaborate with other networks or organizations dealing with the same topics. Here are some examples of meetings we had in the past. So we presented the results from the pilot code project that we launched in 2019. Also some dedicated webinars along to the EU soil strategy and law. We had hotspots on PFAS and also on lead. And in brown, you can see the last topics that were covered by the SOILveR Coffee break. You can get all those recordings and information on our website. And here you can see the link. The second pillar is the knowledge development. So with larger budget, we collaborate between countries to produce some operational results. Can be through a full-scale or targeted action. And for now, we had a pilot call in 2019 with the 3 projects funded that you can see here and that you can have more information on our website. And we are not now currently discussing a full-scale proposal and also targeted actions along with the members' dynamics. If you are interested in becoming a SOILveR member, please come to us. We can give you lots of information and show you how it can work in the concrete. So now maybe I leave the word to our today's speakers. And so I invite Nicolas Magnier to talk to us about the triad approach. Thank you.
Thank you very much. So I will share the screen. Is it okay? Do you see my screen?
We see it. Yes, perfect.
Okay. So good morning, everyone. I'm Nicolas Magnier from the French National Institute for the Industrial Risk and the Environment, and I'm an ecotoxicologist in the Ecotoxicity for Substance and Environmental Media Laboratory. And today I will talk about the triad approach, the procedure for site-specific ecological risk assessment of soil contamination. What I would like to do in this brief speech is to bring you an overview of what is the triad approach, and also bring you one example of application and the potential limitation of such kind of approach. So let's start with the triad paradigm. As you probably get, the triad approach is a method for the ecological risk assessment of contaminated soil, and it can be seen as a holistic and pragmatic approach, also a rational approach to do so. The triad is not something new because it's based on the concept that was previously suggested by Chapman in 1996 for the sediment quality assessment. And basically, triad concept will be the combination of information from different disciplines to enhance the risk assessment. The triad term came from relate to 3 groups of information that you will follow simultaneously in order to make the risk assessment. And this kind of information are categorized in line of evidence. So we have 3 lines of evidence. The first one is a chemical line of evidence for the chemical approach. We will have the ecotoxicological approach under the ecotox line of evidence, and we will have an ecological line of evidence. And in each of these 3 lines of evidence, you will be able to, let's say, perform one or more measurement endpoints in order to make the risk assessment. Within the triad paradigm, there is also 2 other very important concepts. First one is the concept of the weight of evidence. The idea behind this concept is that many independent way, different kind of informations to arrive at one conclusion will provide a stronger evidence for ecological effect. And finally, it will make the ecological risk assessment less uncertain. So the basic is that the weakness of one approach will be counterbalanced by the strength of another. And the other concept is, let's say, it's not concept, but it's the rationality of the approach, because the triad approach will follow a general framework, which is organized by tier, that means by level of complexity, in order to rationalize the number and the type of data that you will need for the risk assessment. And with this tier system, there is always a balance between the minimal information that you need to collect and the effort you need to do. I mean, the technical and economical effort you need to do to draw a strong conclusion on the ecological risk. Just also keep in mind that this general framework is standardized, and you will find the ISO 9204 standard, which describe the general procedure for site-specific ecological risk assessment based on the triad approach. Just keep it in mind, and we came back on this standard at the end of the presentation. Now, if we go a bit deeper into detail concerning this line of evidence, the first one is a chemical line of evidence. It will finally reflect the chemical concentrations, for example, the total concentration, but not only, it will also reflect the potential bioavailability of chemical using chemical extraction, in vivo bioaccumulation assessment in plants or invertebrates or other organisms. And you will also be able to use the modeling at this stage. The main objective here is the calculation of a toxic pressure to the ecosystem and the determination of the potential transfer and bioavailability into biota. Besides this chemical approach, you will have the ecotoxicological approach, which reflect the ecotoxicological assessment of the soil matrix. In this approach, you will be able to perform in vivo or in vitro acute and chronic tests, ecotox tests, mainly monospecific bioassay on terrestrial organisms from different trophic levels. So you will work on higher plants, invertebrate, bacteria, and so on in order to determine the actual toxicity of the soil. And finally, you have the ecological line of evidence, which reflect the actual environmental characteristics and also the functioning of the soil by comparison to a reference site. So here you will be able to make biodiversity survey, for example, soil invertebrate survey or vegetation survey, but also you will be able to test the functioning of the soil, for example, by testing the microbial bioactivity, for example, soil respiration or mineralization of carbon. You will also be able to determine the soil biodegradation capability or the soil enzyme activity and so on. So there is a lot of tools that you will be able to perform in the ecological approach. In the triad approach, the data for each 3 line of evidence will be calculated as an index on the scale of 0 to 1. Finally, you will have a lot of heterogeneous data, and you will be able to homogenize this data and to put it on the scale of 0 to 1. And for each line of evidence, for example, for the chem line of evidence, ecotox line of evidence, and ecological line of evidence, you will put all the results on the scale of 0 to 1. And then you will combine these 3 informations to represent the integrated risk. And this integrated risk will progress on the tier system. So here the tier systems. When you start the triad, to implement the triad approach, you will first collect information for the first year, which will be the simple screening level. So here we will use short, economic, easy handle tools in order to calculate the integrated risk. And then you will be able to determine uncertainties between each line of evidence. So here you will have 2 ways. If you accept the uncertainties, you will be able to directly go to the conclusions, if there is a risk or not. But you have the possibility, if the uncertainty are too important, or if you do not accept the uncertainty, you will have the possibility to level up the assessment and go to the triad tier 2 and refine the screening by adding new data to the tier 1. So here you will also calculate the new integrated risk, and you have also the possibility to do, again, the uncertainty evaluations, accept the uncertainty and go to the conclusion, or go to level up again the assessment and go to the triad tier 3, where it will finally be a detailed assessment where you will add new data, more complex data, or specific data to the assessment. Actually, we have implemented the triad in several research projects. So the first one was the project called Triple, which was an ADEME project, and the main objective here was to implement the triad and bring a feedback on a former mining site. We are actually working on the tripod project, which is ongoing and aimed at determining the main limitations and help to democratize this approach and make it, let's say, more operational. And finally, there is this Horizon Europe EDAFOS project, in which we will also implement triad-like method, but in the context of remediation strategy. So what we would like to see here is how a risk-based method could be relevant for to validate success of remediation strategy, or to determine what kind of remediation strategy are the best. As an example of the triad implementation, I show you here some methods and results from the tripod project. Here you have an example with one of the case study of the tripod project. There is 2 case studies in this project. And the investigated site I show you right now is located in the north of France and is mainly contaminated with metals, because it was close to a former metal industry. And on this site, we have sampled different locations. So it represents different parcels with different characteristics. For example, this one was a parcel which was decompacted and homogenized. This parcel was treated with organic amendment. This one is the initial situations, and we have also this parcel, which is a side border. And on each sample, we have implemented the triad approach to determine the environmental risk. So for example, here is a method we have applied to triad tier 1. So as you can see here, you have the chemical line of evidence, where in this first stage was the determination of total concentration in soils and calculation of the toxic pressure. In the ecotox line of evidence, here you have some results, but we have implemented a test, very short and simple test. The first one was a contact test for solid sample. It's a test on bacteria. It's a very short and very economic test, but it helps you to determine the toxicity of the soil. And we also work on earthworms, performing behavioral test and acute toxicity test. And concerning the ecological line of evidence, here we have made a plant survey, but it was a very simple plant survey because it's only plant cover determinations. And we also make the habitats observations, so by using the current biotope categorization. I directly jump to the tier 2 just to show you. I jump to the tier 2 to show you the methods that we have applied in this tier 2. So here we have, on the chem line of evidence, we have applied measurement of the potential bioavailability, but also in vivo bioaccumulation. For the ecotox line of evidence, we have worked on a long-term test, for example, a chronic test on nematodes, but also test on plants. And finally, for the ecological line of evidence, we have here add information on the soil biodegradation capability, as well as biodiversity on the nematophone. Here are the results obtained for the tier 2. So I just summarize the different situations for each sample. So you will have the index for each line of evidence, and from this index, we have determined the integrated risk, which are more or less quite similar from each sample that we have observed on this site. And then we have calculated the uncertainties, which are more or less the standard deviation between each line of evidence. And at this stage, we could make the decisions. Actually, we have used the threshold 0.4 to decide if we consider that there is not too much uncertainties and when we can stop the evaluations. This point is not scientifically based, but it was already mentioned in several publications, so we use it actually. And for the other situation, as you can see here, the uncertainty was too important to stop the evaluation, and we will go into the tier 3 of the triad approach.
Maybe Nicolas, if you can hurry up a bit, because time is flying.
Stop with this last slide, just to inform you about ongoing activity at the ISO level. So here is to say that actually the standard is under revision. So revision start this year, and that France are leader of this revision, and especially INERIS. And just to put the objective of the revision, that will be to better define the different tier, to improve the current toolbox, and to include example as a feedback from different research projects. I thank you very much for your attention, and for sure I will be able to answer your question at the end of the other presentations.
Thank you, Nicolas. The next speaker, Nicolas, is also invited to share his screen. Thank you.
Okay. No. No. Sorry. Selected the wrong screen.
Yeah, it was.
This one.
Yes, perfect.
Okay, great. So, good morning. I'm Nicolas Pucheux, an ecotoxicologist expert from INERIS, the French National Institute for Industrial Environment and Risks. I'm here to talk about the ecological index of concern, a triad-based decision support tool for screening brownfields and identify which are suitable for an ecological use. Firstly, I want to talk about the context of the creation of this tool. On one end, there is a desire to slow down the loss of biodiversity and to achieve a target of zero net land take to limit the extension of the urban areas. And on the other hand, there are these urban brownfields with low contamination that are home of evolving ecosystems and possibly protected spaces. The question is it possible to change the use of some of these brownfields and give them an ecological use, such as biodiversity reserve, by example? And is yes, that can be done, but it has to be validated by the conclusion of an ecological risk assessment. The problem is that ecological risk assessment can be expensive, and there is little to no funding for assigned to these brownfields. So there is a need for a cost-effective decision support tool that is upstream of the ecological risk assessment. The ecological index of concern, the EIOC, is designed to inform managers if a brownfield can be easily upgraded to an ecological use without carrying out an expensive risk assessment. The EIOC is a management tool intended to be used before performing an ecosystem risk assessment, and it classifies contaminated land intended for ecological use based on the level of concern it presents for the health of the terrestrial ecosystem. It applies to urban or peri-urban industrial brownfields that are contaminated with a short list of metals and PAHs. There is a prerequisite for carrying out an EIOC. The brownfield must sustain an evolving ecosystem. The reason of this prerequisite is that because the EIOC was constructed according to the principle of the triad approach that was discussed by Nicolas, the input data are the total concentration of the chemicals and possibly the bioavailable concentration. This is for the chemical approach side. The concept of the EIOC had been verified by a selection of bioassay. And for the ecological approach side of the triad, the brownfield have to sustain an evolving ecosystem. Here is a figure that represents the decision tree of the EIOC. The EIOC is first calculated for each of the relevant chemicals for each metals and each PAH with this equation. The calculation method is now available on the SOILveR website, and it will be available too on the INERIS website shortly after, maybe a few weeks or few days. So for each calculate an EIOC, you have to take into account the total concentration of the substance and a factor that represents a relative ecotoxicological potential for each chemical. By example, the zinc ETP is lower than the cadmium ETP. The EIOC are then aggregated in the form of two values, one for the metals and one other for the PAHs. Both of these scores need to be below the value of 5 to qualify a soil as one that is of no concern. If that is the case, so it is considered that the residual pollution is not a cause of concern for the ecosystems. And the value of 5 is a value that would be obtained on a brownfield, which if an ecological risk assessment was conducted on such a brownfield, the area should demonstrate that the total concentration are on acceptable levels. If one or both of the value for metals or PAH are above the value of 15, it represents a situation that is a cause of concern. There are not necessarily impacts on the health of the terrestrial ecosystems of the brownfield, and you will have to carry out an ecological risk assessment to assess the situation appropriately, with the triad approach, by example. And if you have intermediate values, there is a need to go further and perform a characterization of the bioavailable fraction of the chemicals. Depending on the results, the experts will decide if finally there is a concern or not. Indeed, we have chosen the bioavailability as a more extensive source of information to complete the decision support tool, which chemicals in the soil may be taken up by an organism. There are numerous tools to measure this fraction of the total concentration. There is a non-exhaustive list on the slide, yes. And on the paper available on the SOILveR website and the INERIS website. The EIOC use the bioavailable characterization to give an approximation of the retention capacity of the soil. In addition to its primary objective, the EIOC is a convenient way to provide information about the health of the soils. would like to thank you for your kind attention. I will be there for if there are questions, and maybe Cécile can continue with the rest of the presentation.
Thank you, Nicolas.
Thank you, Nicolas. I will share my screen. Yeah, is it okay for you? Because I've just one screen.
Yeah,
Okay.
sure.
So my name is Cécile. I'm working in the French agency for the ecological transition, and I participate to the development of this ecological index of concern. So we decided to apply this index in a project of brownfield ecological rehabilitation. The overview of my presentation, we will see the context and the sampling strategy for soil characterization, the ecological and soil diagnostics, and the impact on soil health. In the pictures on the right, you can see the brownfield. We can see the total area is 3 hectares, and part of the brownfield will be used at the housing area, but one part here, it's a natural area, and here we will have a recreational area. So the rehabilitation processes will be we have two different rehabilitation processes because we have two different areas and two different soil users. Then here we can show the pollution mapping, and here we can find two zones with a high polluted soil, and it has been decided to excavate this high pollution and to cover the whole site with topsoil. In this brownfield, we have a part of this brownfield is a white willow, and it has been decided to not to rehabilitate this zona. It's not concerned by the rehabilitation processes. And here we have a grassland brownfield. It's zona with natural vegetation cover, and it has been decided not to rehabilitate this part. What's the causes of the pollution? It has been an old glasswork, and then the area was an old dangerous waste landfill, and then it is dumped for construction waste. This means we have most of the area is contain diffuse pollution, but a small part of this area contain high level of pollution at a deeper level. And the rehabilitation processes is in 2 steps. First, in March 2022, we will have excavation and evacuation of concentrated polluted soil. And the second step will be in September 2023. It will be a covering with 30 centimeters of healthy soil everywhere in the brownfield. We decided to do a sampling between the 2 steps in April 2022 and to be back next year in April 2024. What are the soil uses after recovery? First, the plan for the reuse is the development of business and leisure activity, the development of 74 social housing units, and for public authorities, they decided to develop a green corridors. The objective of the green corridors is used to near the river to restore soil quality in order to provide ecosystem services, especially for biodiversity preservation and a recreation park. Then the following restrictions on use will apply in this area: no groundwater use and no foraging. So what's the sample strategy? First is to compare the soil quality between different soil uses. We have here the reference urban park, and the quality of the soil will be compared to the grassland brownfield, the white willow, and the depolluted brownfield. And the second comparison and the second strategy is to compare the soil before depollution, before the second step of rehabilitation processes, just after depollution and after the rehabilitation processes. The ecological diagnostic has been done to do a fauna and flora inventory and to detect some some protected animal species. And they found some birds which are protected in this area, but there is no protected plant species. But we have found invasive species, especially the Japanese knotweed, which is increased after excavation soil. Then the soil diagnostic has been done in different parts. First is a healthy soil used to cover the soil after excavation. We decided to know more about this healthy soil. We made diagnostic in the Riffen-Tuben Park, in the grassland brownfield, in the white willow, and the depolluted brownfield. Then we can see immediately that we have two kinds of soil. The soil control and the Riffen-Tuben Park, we can see natural soil with different layers, and the surface, the natural soil is in surface. But in the brownfield is completely different. It's the layers are not so distinguished, and we have more backfill materials and sandy soil and the coarse element. So the diagnostic is done first in surface, and another sampling has been done underground. In situ measurement we have done in situ measurement and laboratory analysis in order to calculate an average score based on parameters aggregated by function. The wall parameters are graded from 0 to 3 based on benchmark available in literature. So then we decided to calculate the soil function for organic matter recycling, carbon storage, nutrient supply, water retention, water infiltration, plant rooting potential, and habitat for biodiversity. And here we can find the wall soil indicators that can be used to calculate this soil function. We realized immediately that we are not able to calculate the capacity of the soil to filter and to retain pollutant from the chemical analysis. Here you can find an overview of the calculation of ecological soil function. We have the function here and the parameters, and there are we have the score from 0 to 3. The 0 is bad quality, is red, and when the score is 3, it's a good quality and it's green. We can see immediately that for the Riffen-Tuben Park and for the white willow, we have most of the time a green color, but for the grassland brownfield and for depolluted brownfield, we have more orange and red color. Another way to represent the soil function, it's to represent in a diagram. You can see in yellow the Riffen-Tuben Park, where a lot of soil function are achieved. It's the same for the white willow, but for grassland brownfield and depolluted brownfield, in blue and in red, we can see that the soil function are affected. If now we calculate the index, the ecological index of concern, most of the time it's between the minimal and the maximum value, and some for Riffen-Tuben Park and white willow, it's just above the value, the maximum value. This means for Riffen-Tuben Park, white willow, and depolluted brownfield, we can do bioavailability measurement, and this will be done to check that the low level of pollution is acceptable for the ecosystem. But for the grassland brownfield, where there is a natural vegetation cover, the high level of pollution explains this high level of ecological index of concern. This means in such area, we have to perform the triad approach, and we have to perform ecological risk assessment. If now we transform the ecological index of concern in pollution index, we decided to, for an index for minus, when it's under 5, we decided to put an individual score of 0. When the index is between 5 and 15, the score is minus 1.5. And when the index is above 15, the score will be minus 3. And we decided to make the average of the score from meteorical index and pH index. So here you see the transformation of the ecological index of concern in a pollution score. And we can find, so for the white willow and depolluted brownfield, a score is minus 1.5. It's the best score. It's in minus because it's affected soil pollution. So we decided to create a score negative. And for reference urban park, this is minus 2.2. This means it's not a good score, but anyway, it's still between 0 and 3. And for grassland brownfield, we have a score minus 3. This is linked to the fact that this is explained because there is a high level of pollution and high ecological index of concern, and the tiered approach has to be performed. And when we compare and when we put all together the index pollution with the score for ecological soil functions, we can find that for the reference urban park, we have a score of minus 2.3. But anyway, we have a lot of soil function that are still alive and are still function. The soil is functioning most for a lot of, the soil has a lot of function, ecological function. So this means this low level of pollution can be acceptable for the ecosystem. For white willow and depolluted brownfield, we have the index, the pollution index is minus 1.5, is a low level of pollution, and we can see some ecological function are still alive, but it's less than the reference urban park, and maybe the rehabilitation processes can increase some soil function like the organic matter recycling. But anyway, we can say that with a viability measurement, we can check that the low level of pollution is acceptable for the ecosystem because some ecological soil function are still alive. And for brownfield, for the grassland brownfield, we have an index pollution minus 3. This is a bad level, it's a bad quality, and ecological soil function are also very low. This means an action has to be done in this area in order to increase the soil function. The ecological index of concern is a useful and complementary tool for comparing anthropogenic soil. The reference urban park has the best ecological function, even if the score of EIOC is not optimal. And because the white willow and depolluted brownfield has a better EIOC score than the reference urban park, this means the ecological index of concern is very sensitive. And white willow and the depolluted brownfield, they have an ecological interest, even if there is a low pollution level. And the maximum limited value above 15 can be raised up for land planning management purpose. Thank you for your attention, and don't hesitate to ask a question after the presentation. Thank you.
Thank you very much, Cécile. Ingrid, I don't know if you have seen some question in the chat. I'm not sure that I did until now.
Yeah, there's one question from Paul Trenning. Could you describe a bit more how you used the ecological system measurement endpoints to determine impacts on soil functionality. How did you connect these to specific soil functions?
Maybe the question has been done before my presentation. I don't know. Yes, we decided to transform the index of concern in a pollution index. And I explained that we put a score of 0 when it's -5, and between 5 and 15, it's -1.5, and with above 15, it's a -3. So this is a low score, -3. And we decided to create a negative pollution score compared to the other ecological soil function.
The EIOC is firstly designed to screen to make a screening between the abandoned brownfield, sorry, but we wanted to show you another use of the tool by the work of Cécile.
I think in the paper, you received the paper, I think yesterday, maybe there is a paper linked to this presentation, and the calculation is explained on the paper.
They are online. I saw it.
Yeah, it's online.
That was the only question in the chat.
I have one question.
Okay.
To Cécile, you try to integrate the different soil functions together, and the only negative score is then the pollution score. Does it mean that it's always at the final a good soil? I mean that really to have a total score, a negative score, then you need to have a very, very high pollution, such that at the end, the number of soil that should be like considered as not healthy would be very low, because it's just because of a very, very high concentrated pollution.
Yes, the main objectives of this index is to compare the soil, and the Riefentuben Park. When you see the Riefentuben Park, it's a vegetation cover, and grassland brownfield, it's a natural vegetation cover. And if you see both area, it's similar. So it's very hard to see if the soil quality, how it is when you look at the vegetation. And it's hard to say when you have pollution and you have low level of pollution, it's hard to say it's okay for the ecosystem or it's not okay. So the ecological index of concern help to say that, okay, we have low pollution, we can do some viability measurement, and we can decide that the low pollution can stay because soil function are achieved by soil, and there is an ecological interest to preserve the soil, even if there is a low pollution. And this was the objective of the example, the application. How to say, okay, there is a low pollution, but it's better to preserve the soil, even if there is low pollution, compared to other polluted soil, where the pollution is low, but there is no ecological interest. So maybe it's better to excavate soil or to cover with topsoil, because the soil in depth is not good.
And did you apply that method to many sites?
We apply this method to 2 other brownfield, and but it's not sufficient. Right now, we can see a difference, and this was the first objective is attained, because we make difference between different areas in brownfield. So we make the difference, so that's good. But anyway, I think we need more experiences, and especially about the maximum limited value of 15. Maybe we have to work on this limited value.
Okay, thank you. Ingrid, I don't know if you've seen other question meanwhile.
No, I don't see any questions in the chat anymore, and we're running out of time.
Yes. So yeah, then I want then to thank you all, the two Nicolas and Cécile, for their presentation. That was very interesting and approach for the ecosystem part of the pollution, which is sometimes more difficult to tackle. At least now we have some principles and lines on the subject. It is available also, more information is available on the website, on the SOILveR website. And I thank all the participants who have stayed with us for that for today's coffee break. So I leave you with that and have a nice afternoon, let's say. Thank you very much.